Hello everyone, this is part 2 of section 15.5, triple integrals. We left off with a sketch of a plane, what we call a tetrahedron in its standard form, and a theorem with regards to volume. And with regards to this volume formula, it's really in general a situation where you might have, let's say, just some surface, call it G2, that's above, I don't know, some other surface, call it G1, and you're in the the three-dimensional system, and you basically just have a rectangular region here that is, it doesn't even really need to be a rectangular region, but whatever the region is. And it's basically, if you consider what that would look like on each of these surfaces, and they're not just planes, it could be any kind of surface, that's the volume that we're finding here. Okay. So that's kind of like a general idea of the theorem, but it involves just setting up the limits of integration for z as the lower function and the upper function, and then whatever the region is. Again, it doesn't have to be rectangular, it could be any shape. Okay, so an example. We're going to find the volume under this plane in the first octant, so that's why we went through that example earlier where we sketched out the tetrahedron. So we identify it as being a plane in the first octant, call it a tetrahedron. We'll get it in our standard form by dividing everything by 2, or excuse me, by 4. Okay, so then that gives us x over 4 plus y over 4 plus z over 2 is 1. And then we can sketch what it looks like. And so our intercepts for the x are 4, for the y it's 4, and for the z it's 2. And those are the intercepts, so then basically a little plane that slices like that. Alright, so that's what the sketch of it looks like, and this region here is the projection in the xy plane. And we're going to need that. So if you consider just the xy plane, y-intercept is 4, x-intercept is 4, straight line there, so that's the region, and we'll need the equation of this line. So the slope is -1, you get change in y over the change in x, so that's going to be -1, and so the equation would be y equals -x plus 4. Their y-intercept is 4. Okay, so for the volume, the formula for the volume is the double integral over the region from, I'll call it G1 to G2 of dz dy dx, or dx dy, it's your choice. But I'll go with dy dx here. But it's always dz first. And z, these functions, g1 and g2, have to be in terms of z. Now, the lower limit of integration here is going to be the xy plane, which is z equaling 0 in the xy plane. And the upper limit of integration, g2, so g1 is going to be 0, because that's the xy plane. And g2 relies on, is going to be our function, the plane, the tetrahedron. So if we, let me do it this way, I'll say for g2, we have that x plus y plus 2z is 4, so therefore 2z would equal 4 minus y, and then dividing everything by 2, we get z equals 2, I'm going to write it minus 1 half x minus 1 half y. So that's going to be g2. So now setting the volume law. So basically right at this point we've got, let's just do it this way, we'll do it in 2 pieces. Well, first we'll worry about the region in a minute, and we'll now just state that the limits of integration are going to be from 0 to this function 2 minus 1 half x minus 1 half y, and then dz dy dx. Okay, so now we need the limits of integration for the region. So that's the projection in the xy plane. So we've got the volume is equal to, let me space these out a little bit. This is 0, this is the 2 minus 1 half x minus 1 half y. Okay, and if we're doing it in this order, dz dy dx, that's probably going to be the best order to choose, because typically the projection, you'll have a function for y in terms of x. So, and if you consider vertical strips here in the projection region, so where x is going to be fixed, because x is the outer, and if you consider little vertical strips, we're going from, y is ranging from 0, so that's the x-axis, to that straight line, minus x plus 4. And x is ranging, to take all the vertical little strips here, x is going from 0 to 4. Okay, so that's the setup for the integral. And so now just the calculations. So doing the calculus now, 0 to 4, integral 0 to negative x plus 4. Okay, integrating dz with respect to z, that's just 1 dz. It's always going to be this way because it's always just dz dy dx. That's going to be z. And that's evaluated, goes from 0 to 2 minus 1 half x minus 1 half y, and then with respect to y, with respect to x. So that gives us, the upper limit goes in, so that's, so I'm going to recopy integral 0 to 4, integral 0, negative x plus 4, upper limit goes in, so that's 2 minus 1 half x minus 1 half y, but then no need to really show the lower limit at 0, since z is 0, that's just minus 0, so I'll just leave that out, and then dy dx. Okay, so now we integrate with respect to y, and we get integral 0 to 4 of, okay, 2 is a constant, integrating with respect to y, we'll pick up the y, minus 1/2 x is a constant, integrating with respect to y, we get minus 1/2 xy, but then integrating y, we get y squared over 2 times the negative 1/2, so let's say negative 1/4 y squared, as y ranges from 0 to negative x plus 4. And that's going to be with respect to x. Okay, so now the fundamental theorem of calculus, upper limit goes in, so integral 0 to 4, let me show it this way. Upper limit, negative x plus 4 is y, so 2 times minus x plus 4, minus 1/2 x times minus x plus 4, and then minus 1/4 minus x plus 4 quantity squared. Okay, so that's the upper limit, then minus the lower limit. But the lower limit's 0, and y is a factor of each of those terms, so that's just going to simply be 0. And that's all with respect to x. Okay, so now we got to clean this up algebraically. So the integral 0 to 4 of minus 2x plus 8 plus 1/2 x squared minus 2x, and then minus 1/4 here times, we have to expand this negative x plus 4, so take it off to the side, FOIL it out, excuse me, we get x squared minus 8x plus 16, and that's all with respect to x. Okay, cleaning that up further, again the integral from 0 to 4 of, let's see, we've got a negative 2x, negative 2x is negative 4x, and this would be a negative 1/4 times 8x is positive 2x, so negative 4x plus 2x is negative 2x. We got 8, and then minus 1/4 times 16 is negative 4, so 8 minus 4 is plus 4, and then we have 1/2 x squared minus 1/4 x squared, which gives us plus 1/4 x squared, and that's with respect to x. So a little bit of algebra, and now finally integrating with respect to x. We get minus 2x squared over 2, so just minus x squared, plus 4 integrates to be 4x. This is going to give us 1/4 x cubed over 3, so plus 1/12 x cubed, and then that's going to be evaluated as x goes from 0 to 4, and no need to write it. X equals, and so finally upper limit, minus 4 squared plus 4 times 4 plus 1/12 times 4 cubed, and then minus lower limit. It's nice that it's a 0. And finally we get our volume is, okay, this is negative 16, that's 16, so that goes away, so that's 64 over 12 then, which reduces to 16/3. Okay, so nice example there, and to finish off this section, consider the average value of a function. So that's going to be the triple integral of the function with respect to the volume. which really gives us the total mass of the function in a physical situation. So the numerator is the total mass, and the denominator is going to be the volume. So therefore, this F average can be thought of as the average density, because density is mass over volume. So in any event, we just have to basically grind through and obtain. Got a little technical difficulty here, hold on. We just have to grind through and obtain, there we go, the numerator and the denominator respectively. So here's our example. Over the region, okay, so I need a sketch for the region here. So the region's going to be where we have an x and y values of 2. Okay, so rectangular region, basically 2 by 2 at the bottom. And then we get a plane coming up, okay, where z is 4. We're going to have an intercept. And we're going to bring this up 2 units. And we're going to bring this up 2 units as well. And this is what it's going to look like. It's really like a plane slicing into a box. Okay, this being the plane slicing the box. All right. So, and this is where that plane has the equation of z equaling 4 minus x minus y. So it's really a tetrahedron, but we kind of cut it off and we didn't extend it, all the way to the y and to the x-axis. So that's the region that we're considering. So therefore, the average, F average, okay, again, is going to be the triple integral over the region G of the function f of x, y, z times, and then you could say the differential of the volume, just as we set up here, and then over the volume of G. So the triple integral of dz to y dx we'll use. Okay, so the first thing is I'll go for the denominator. That might be easier here. Triple integral of dz dy dx. Really just the volume of this little sliced up box. So we're going from, just similar to the last example, 0, the xy plane, to this function, 4 minus x minus y, and then both the x and the y, you can draw it if you like, projection in the xy plane. Really not necessary because you couldn't get any simpler than a 2 by 2 rectangular region. So therefore x and y both going from 0 to 2. Okay, so then we do the calculus here. Integral 0 to 2, integral 0 to 2. We get z evaluated from z equaling 0 4 minus x minus y dy dx. Okay, upper limit goes in, integral 0 to 2, integral 0 to 2. Upper limit 4 minus x minus y, but then minus lower limit of 0, not necessary. So dy dx. Okay, integrate with respect to y. We get the integral from 0 to 2 of 4y minus xy minus 1/2 y squared. Evaluated as y goes from 0 to 2, and that's with respect to x. And then upper limit goes in, so we put a 2 in for y. So we got the integral from 0 to 2 of 8 minus 2x, and then this gives us 4, so minus 2. That's with respect to x. So you might want to make that simpler. Integral 0 to 2 of 6 minus 2x with respect to x. Okay, we get 6x minus x squared. Evaluated from 0 to 2, so that 6 times 2 is 12, minus 2 squared is 4, and minus 0 goes in, so we get 8. Okay, so our denominator is 8. Now the numerator. So the numerator is the triple integral over the region G of this function. Oops, let me move up here. Of the function, and then dv, again, we could pretty much say it's anything in terms of dx, dy, dz, dz, dy, dx. That's what I'm going to choose, dz, dy, dx. So that's the integral, triple integral. Okay, and now we have essentially the same limits of integration. 0 to 4 minus x minus y, 0 to 2, and 0 to 2. But now we have the function x, y, z. And again, we'll go in the order dz, dy, dx. Alright, so this is going to get a little bit tedious, but let's just grind through it. So we have 0 to 2, 0 to 2. Integrating with respect to z, we get z squared over 2, so 1/2 xy z squared. Evaluated. Fortunately, these lower limits are all 0, so at least it makes it a little bit less painstaking. Okay, and dy dx. Upper limit goes in, so this is where the algebra gets a little tedious. So z is 4 minus x minus y, so we get 1/2 xy times 4 minus x minus y is a quantity squared. And then that's dy dx. So now we have to square this 4 minus x minus y. And so off to the side, that'd be 4 minus x minus y times itself. And I can't think of another way but just to grind those out. Triple distributive, 4 times 4 is 16, 4 times negative x minus 4x, 4 times negative y minus 4y. See, minus x times 4 minus 4x. I'm going to be clever here and line it up neatly. Minus x times minus x would be minus x squared. Put that out to the side. Minus x times y minus xy. Okay, and then we've got the y, negative 4, y being distributed, so negative 4y. Line that up here. Plus xy. Put that here. And then plus y squared. So adding all that, 16 minus 8x minus 8y minus x squared. The xy's go away. Looks like they go away. Do they go away? No, because I made a mistake here when I did the negative x times the negative y. It was supposed to be positive xy. And so therefore, plus 2xy plus y squared. Alright, so all that stuff replaces the 4 minus xy that's being squared. 4 minus x minus y that's being squared. So 16 minus 8x minus 8y plus x squared plus 2xy plus y squared. And that's all finally going to be with respect to x. Okay, so now we have to distribute before we can integrate. So the integral from 0 to 2 of the integral from 0 to 2 of then distributing, this gives us 8xy minus 4x squared y minus 4xy squared plus 1/2 x cubed y plus x squared y squared plus 1/2 x y cubed, all with respect to x. And now finally integrating that, the integral from 0 to 2 of, I would never give you something this complicated, but let's just deal with it. Okay, now we're integrating with respect to, but backtrack here, it was with respect to y, then x. So based on that there. Okay, so y squared over 2 would make this 4xy squared minus y squared over 2 again, 4x squared y squared, 2 x squared y squared. This would be minus 4/3 xy cubed plus 1/4 x cubed y squared plus 1/3 x squared y cubed, and finally plus 1/8 xy to the 4th. And that says y goes from 0 to 2. And then that's with respect to x. Alright, so now crunching that down. Still the integral from 0 to 2. And then we have a 2 in for y. Okay, so that makes 4 16x minus 4 8x squared, 30 minus 32 over 3x. See, 4 cancels, plus x cubed, 64/3 x squared, and 16 divided by 8 is 2, so plus 2x. So the integral from 0 to 2, see if we can simplify anything here. Well, we got the x cubed, it's going to stay. Let's see, this is minus 24x squared plus 60, minus 24 over 3x squared plus 64 over 3 would give us plus 40 over 3 x squared. The x's give us 18x, and then that's it. That's all with respect to x. Alright, so finally, well, not finally yet, but close to finally, 1/4 x to the 4th plus 40 over 9 x cubed plus 9x squared, evaluated from 0 to 2. So let's see, that's 16, 4 plus 64 times 40. Gonna get a calculator for that. 64 times 40, 2560 over 9. Oh, that wasn't 64, that was just 8 times 40. I'm sorry. So 320 over 9 and 436. And then minus a big 0. So that's 40 plus 320 over 9. Yeah, I'm using a calculator here. So 680 over 9. Okay, so then finally, F average. I got a little out of control. F average would be the 680 over 9 divided by the original volume that we had. What was that? That was the 8. And let's see if yeah, this reduces to 85 over 9. Okay, I could have made a careless mistake in there, and if I did, I apologize. So don't take it as gospel, because in my notes I noticed I made a careless mistake here, somewhere over here. Yeah, so it came out different than what's in my notes. So I just did my best there to finish that off. But yours would be a lot simpler, and in fact, probably nothing like that on the exam, but just shows you how we can get some pretty complicated situations, or at least tedious. I don't say difficult.